Well, seems like we're going to do a tired stream. I don't really know what I'm going to do now. It's just, I'm going to look and I'm just going to look at the polymorphism stuff and see if I have any ideas about what to do. My current assumption is that when we add value bakes, because we established before that they have to be added, when you add value bakes, I guess they will always go after polymorph parameters and in lexicographical order. Or an alternative idea that is cleaner but annoying and maybe less efficient is to create a bake scope that only has value bakes and to still keep them kind of separate from the no, I mean, I don't like that. I don't like that. I don't like it at all. I could not worry about the order yet. I could to-do the order for later. Because if you don't match your polymorph because you bake things out of order, the worst that's going to happen is you'll just polymorph it twice, and that's not so bad. Right. Right-o. So on the lambda, I can record an integer that says how many types block entries there were from type bake. No. No, actually, the other thing that'll break, so if you bake in opposite order, the other thing that'll break is the comparison will get more annoying. Okay. And that, actually making a separate scope doesn't solve that. So I'm just going to have to do a sorted insert if you bake and there's more than one bake. And that's fine. I can just insert it and frickin' Q sort it. But yeah, I can postpone that because the demo is not going to trigger that condition, so I don't have to worry about that yet. So I'm going to go back and I'm going to re-enable those asserts that I had typed before and then reverted, like types, blocks, match. I'm going to say, oh, I did check that in. Okay, that was before I reverted that I checked that in. I'm going to say incomplete. Okay, this assertion is wrong now. Incomplete. The assertion that names match will fail in the case that we bake two different procedures incrementally in opposite argument orders, since right now we append value bakes to the types block in the order they happen, so this will happen in opposite, so they will end up with bakes listed in different orders. We can fix this by sorting every time we bake, but right now I am just going to get basic thing working. Okay. And I've already got on my to-do list to chase down all the incompletes in this file anyway. Or no, in the app file. Incompletes in polymorph.cpp and demo poly. Yeah, you know, we will consider beta testers at some point. It's just the language isn't quite far enough that beta testing is a good idea. But there's just still some major stuff has to happen. But yeah, when it's ready, we will certainly do that. Okay. So, what I'm going to do to make this loop easy is I'm going to make a new variable called number of it types block it number of initial polymorph type matches. So this is just going to be the number of things that there were before there ever was a value bake, which we know is the same for everybody, for any clone, any polymorph clone of a particular procedure. So let's go add that. I'm going to have int equals -1, and we're going to set that in infer. Let's try in infer, not in parse. Because if we do it in infer again, then the user doesn't have to know about this or set it, right? Because remember, we could always bypass the parser later on. Or in, so okay. I'm just going to do it here. Lambda. I'm going to make sure that we only do this once. I'm not sure that's completely true. Lambda types block members dot items. So, you know, when we come through infer, which we have to before anyone can use it to polymorph, we check that those are equal. So now I actually never made that check types blocks match take the extra parameters that I passed when I called it, right? Whatever. Yeah, functions not take 5 arguments. Let's go back there and get that. Types, blocks, match. yeah, block A, int num, what was that variable called? I don't remember now. Int members A, well, num to check A, int num to check B. And we'll just say, you know, so first of all, if these are not equal, although no, we should assert actually, I guess we should assert this at the following site since there is only one and pass just one parameter. Oh well. Is that true? No! This will not work. Ah! This will not work. Okay, the reason this will not work, man. I can't do this in infer. Because you can bake a parameter on a thing that's not fully polymorphed. And that would put it in the types block, and then that would get inferred. So we have to put this in the parser. Well, where do I add stuff to the types block? Add to types block. Okay. Woo, woo, woo. Okay, so this will be a problem later if we can make a new lambda by bypassing the parser. But I'm not going to, I've got enough problems right now. I'm not going to worry about a future problem yet. Because I may end up implementing it this way, in which case I would make it robust to that, and I may not. I may end up reverting this or doing something else, so I'm not going to panic too much over it. Equals, yeah. I mean, maybe I should just assign this in add to types block, like I should factor it that way, but we'll see. Okay, so I've set that value. I need to copy that value when I make a new lambda, which is easy. Well, I can do this. I just have a macro for that. Lowercase c. Programming is fun. Is there some list you could get on? I don't really have a list right now because I've just got enough to think about. So, you know, maybe later. So, let's see what happens. Oh, right. Well, that is no longer, that no longer applies. I deleted part of it, but not that part of it. All right. Okay, so oh geez. Wow, guys, I reverted too late. Because this shouldn't be happening anymore. So I've got too many add to types blocks. Oh boy, this is gonna be fun. Is this for? That's for quick lambda. This is for, right. This is the new one that I added. That is no longer a thing. Comes from, not came from. Okay, so I want to go back to pooping all over the argument declaration. Really. Hey. Okay, so that's all not that surprising that all this works. It's just we're getting back to a spot of sanity. The one actual material change there is that I've got this new member that tells how many actual polymorph matches are there. So now if I add bakes after that, that won't go wrong. And I can assume the names are the same. So this is all good. That's an improvement. That's an improvement. That's an improvement. Okay, so minor work toward simplifying polymorph value bakes. Attempt number 2. Yeah, I have not been programming consecutively all this time. No, it's not overloading. It's like, if you know C++, it's like templates, but it's a better version of templates. This version of polymorphism, so polymorphism has meant different things in different language communities. So like, if you look at functional languages that do polymorphism, like, you know, ML or something like that, they tend to be more meaning it this way. Okay. So what I would like to do now, maybe this is going to massively break the value bakes, but like I said in the previous stream toward the end, I think I'm going to start attacking them top down. And what that probably means is, let me just start looking at this code. Okay, so if I'm going to apply bakes to procedure arguments, I find them. Bakes on a using parameter. This may just work now. Okay. Find this guy in the destination lambda's arguments block, move him to types. Okay, this is the regular code that we were just looking at and changed back. Let's change this. I always prefer to do things this way. Descope. Let's make sure we didn't break anything there. Just being real cautious. All right. So, okay, so this does pretty much what we would expect. So who calls it? Apply value bakes to procedure arguments. Oh boy, okay, this is in the polymorph super function that does everything. For value bakes, we test now. For duplicates, we tested non-value bakes earlier in this procedure. Simplify. Yeah, oh god, this is super gross. Like this rollback action. Oh. Oh, yeah, this is some of the things that I would like to get rid of. Oh boy. Value bake detected as duplicate using prior procedure. So it's like we do one polymorph well, no, we don't really. I have a feeling this is not the only two-phase thing. So basically, yeah. Before we make any names, we already generated this version. Yeah. So this is weird. It's like I'm calling this in two different modes. If I have value bakes, then I'm only baking values. And if I don't have value bakes, then I'm not only baking values. So I would like to combine them all into one. Which means this modalness is not good. So what I really want to say is, if I can just move this down to be next to the value bake, check for duplicate that's below without breaking anything. Oh, I need to check that. Oh, this is probably because copy doesn't do the right thing. Copy the return declarations. Copy the argument declarations. See, I have to copy the argument declarations before I apply value bakes to procedure arguments, because I modify the argument declarations. But it's less efficient to copy the argument declarations. But you know what? Screw it. Screw it. Okay, here's what I could do. I can move this to move the returns block to after all this stuff. So let's see if that, I don't think that'll break anything. Oh, wait, that looks like a small mistake though. Okay, so argument declarations. You probably did it start copying. No, I don't know. This start copying and stop copyings are supposed to be paired. I feel like I've got an extra one floating around somewhere now. Whatever. I don't flood repeats because I have so many comments. It's just, it's easier to see them or pay attention when it's the same thing multiple times in a row. So if it's something that I feel is higher priority to think about, I tend to spam it a little bit like that. But like I said, this whole body of code, the whole reason I'm here doing this today and apparently for the next few days is because I've been thinking about cleaning this up for a while. It's something that I've wanted to hit, and so this kind of comments in here are why I've wanted to hit it. Let me just see, copy block for polymorph. Let me see, does that still exist? Copy block, copy block, does that exist? Copy block. Block. So what does this do? Copies location info, sets the block type, flags. Do members pops. Well, let's try it. Right? But what's in rets? That should get copied already. Why? Oh, what was that? That was some Windows thing that just happened. No, I don't want feedback hub. For lambda returns block dot items or dot members assert that this should get copied, this flag. So I don't know why I was setting it explicitly. That might be really old code. Copy block is not a member of typer. Oh, it's copier. Right, just like above. Just like above. Left of members. Left of members. This is another thing that's offensive about Visual Studio. Just highlight the frickin' errors in this instead of, yeah. They have this really annoying error report thing that's horrible. And they just don't do the simple thing of fixing the output. Yeah, okay. So that's good. So this was already a minor victory because, hey, we can do this now. That got rid of a few lines of code at least. That runs. That runs. Minor cleanup victory, which means the arguments block copying I can also change to a copy block. Again, I should that flag should get copied. It must have not been copied in the original version of the compiler. Original, but you know, a long time ago. And those are no longer necessary. Yeah, those are no longer necessary now, which means so waves. Okay. So I'm just factoring those two things apart. Oh. I broke something. Oh, right. No. Let's just do this. What I was trying to work toward was doing this again. So let's just do this right away. Instead of returns, this time it's arguments block. No, I still broke something. Why is that different? I mean, I'm confused by this because put arguments into lambda just puts stuff into the arguments block, which we just copied things into. That doesn't make sense to me. For arguments, flag them again, yet again, redundantly again. Check the add to scope to the art. Yeah. Okay. I'm going to assume that we don't need to do any of that here. But I'm going to assume that we can just do that. No. All right. So this is when we hella revert. Okay, that didn't work. I didn't revert far enough. So the reason we're not calling an abstracted block copy here is because we want to explicitly put arguments in the lambda because it does some flagging that we need. That's okay. I'll leave that for a while. It's not necessary. This would only save us a few lines in the meter. It's not that good. But if we can, to the extent that we can do it, it's good to do. It's just not critical. This is copying the procedure body. Let's put this up here. Get rid of a couple lines there, so we don't have to start and stop copying so much. Don't have to start and stop copying so much. All right. This doesn't deserve such a big comment. Infer. I'll leave that comment for now. Might need it. Yeah, this function is much less scary than it used to be due to prior cleanups. So that's good. So now I'm just going to turn off part of my programmer brain and not worry about efficiency so much. I'll maybe make a comment. Unfortunately, we spent some memory by copying declarations, which we would rather not do if we end up returning a matching lambda and thus not completing this polymorph. Maybe we can find a way to reorder this. Maybe we can, and maybe it's time and memory that we spent. Okay. So now, if this works, I've got these two checks for matching polymorph next to each other. And that may be enough to do for tonight because I'm tired and I'm not going to try the challenging thing. But the thing would then be to apply value bakes before I check the matching. In fact, actually, I can go that step if this works. That worked. And that worked. Yeah, well, let's make sure it runs. Still good. SUN commit. Factoring polymorph. Factoring types, block, match, checking. To be next to each other. This will be so good if I can simplify this out. Okay, so now I can do this two things separately. I can apply value bakes first and then do both of these match checkings. See if that works. Oh yeah, feel good about it. This is the debug version of the compiler, by the way, which is why it's so slow. Oh yeah, okay, this makes me feel good. So this looks like more code because we split this into two parts with an extra if, but really this if is going to like go away. So what, like tomorrow when I'm awake, what I'm going to do is make find matching polymorph, know whether there were value bakes or not, and to test the bakes separately from maybe I'll have another integer of like just the number of bakes that we've put in. Because we've got an integer now for the number of non-bakes. That seems plausible. This is a good victory point for tonight, even though it's not a dramatic cleanup. This is on the border of a dramatic cleanup, because one of these blocks will get deleted entirely, and then that means that this procedure doesn't need to be modal anymore, I think. And it not being modal then means we're on the route to simplifying the caller. Out variables are really great. I don't think out variables are really great, but hey man, to each their own. I can't do more Zelda tonight, folks. I don't know if I ever can. Let's see. Yeah, I mean, the compiler itself is in C++, so I am programming C++ when I work on the compiler, such as right now. And then the test programs are in the new language. Okay. So tomorrow, I will whoops. I said check the types match. That's totally the wrong procedure. It's find matching polymorph. So yeah, tomorrow the goal is going to be in the morning to make find match polymorph and its callees work correctly for any mixture of bakes and non-bakes, and then I don't need these ifs, and I can just do one of these. It'll be great. Maybe this should do the rollback instead of, I don't know. See, like this dependencies that were added here to cover a bug really should be down here too. It's just a bug that they're not down here because I missed that when I put these in. So unifying these code paths, will eliminate the possibility for that kind of bug. All right, I feel good about this, but I am an hour and a half past my bedtime of late, so I'm going to go to bed. Thank you for coming by. See you guys all later.